Okay, this is Leetcode 235, 253. 253. And this is a very common question that I've been asked many times in meeting rooms 2. So essentially you're given a list of lists that have a start time and an end time, and you are trying to figure out how many rooms you need to have all of these meetings, right? It's a pretty simple real world problem that people have that's actually a little bit more complex when you try and convert into code how many meeting rooms you have. But I think what makes sense for me is to just draw a graph, right? And you have start times on the x-axis, or how long it takes on the x-axis, and then what goes up here, or the meeting rooms, right? So we have like here, meeting 1 starts at 0:30. Let's just say meeting 1 here, and then so this is, let's do 5, 10, 15, 20, 25, 30. So meeting 1 goes from 0 to 30, right? 5 goes from 5 to 10, and then 15 to 20 goes here, right? So we'll have 1 here, 1 here, and then 1 here. 3 meetings total, and we can see that there's overlap here, but at any given time, there's only 2 overlaps, right? There's 1 here, and there's 1 here. Let's say this one were to be, instead of 5:10, but 5:25, then this would go all the way to this way. And when we draw a vertical line from here, we see that we need 3 meeting rooms. So that's kind of conceptually how I visualized what would be a right or wrong answer. But yeah, that's how I saw it. And then I actually do remember doing this question a long time ago for an interview. I didn't get it right. I had no idea how to do it, and I didn't even revisit it, which was a mistake. But yeah, I'm revisiting it now, which is better late than never. So yeah, let's get started. So these are intervals: start time, end time, right? And we can define our function signature to do, oh yeah, and we're returning the number of meeting rooms we need. So meeting rooms takes in some array, and then we were just returning an integer. Int number meeting rooms. So we need some sort of count, right? Rooms equals 0. So let's actually think about how we want to do this. So first, this one's already sorted. Come up with like another example. Well, let's just say this wasn't sorted. What we need to do first is actually we need to use the properties of like a sorted array. So at first we'll sort arrays.sort. Array.sort, which will give us this, right? And actually what we want to do is we want to maintain a min-heap of the end times. So here, we know that we need 2 rooms because we did that graph thing, we did a line over it. So when we go here, we're going to have, this is a min-heap, so we're going to have 30 first when we're going to iterate from left to right. We have 30 here, and then we want to go to this next element, and we see that 5 is less than 30. We see that 5 is less than 30, so we put in its end value. into the min heap. Since it's a min heap, the 10 will bubble up, and then 30 would remain. And then the next thing we do is we go to this one, and then we see that 15 is actually greater than the root of our min heap. So what we want to do is remove the 10, keep the 30, and replace the 10 with the new end. So now we have 20 and 30, and all we need to do is return the length of our min heap. So let's go over the code first, and then I'll explain why that works, if I can do so. So yeah, in Python you're going to want to import heap queue, and then I'm pretty sure the heap queue just defaults to a min heap. Yeah, rooms array.sort heap queue heapify. I'm not sure if you actually have to do this, but let's do that, turning it into a min heap. For I in, do I need to do I? So we're just going to start and end. Yep, let's just call it I. For I, or for int, that's a keyword. ITV, let's do. For ITV in array, be this. If, so array is our heap. If, oh no, we need something to put our elements in. So this is wrong, or this is fine. Array.sort heapify, but we need to create like a results array that we are going to heapify. We're not heapifying this. Res. Yeah. Here we go. So if length of res is greater than 0 and ITV start, which is the 0th element, right? These are going to be the 0th elements to start is. And ITV is greater than or equal to res, yeah, we should name that better. Let's call this heap. The root of the heap should be the 0th element. Then we want to replace it, right? And how do we do that in a heap? We will do heap queue, heap pop, from our heap, and then heap queue, heap push, heap, and the end element. ITV, a comma, like so. And then otherwise, we would just push it onto our heap. Q.heap. Push ITV, the end. We're only storing the end intervals in our heap. And then at the end, like I said, return length of heap. So yeah, let's go over this one. So we're sorting it, it's already sorted. We're heapifying our heap, which is empty at first. So for each interval, if the length of the heap is greater than 0, which it isn't, so we're just going to add 30 into our heap. And then going over to the next iteration, we'll we'll go over a different example after this. Yeah, so next one, the length of the results is greater than 0, which it is, right? And this is supposed to be heap. And interval of the start is greater than the root of the heap, which it isn't. So we'll just go to the next one, and we're going to push 10 into our heap. And since it's a min heap, the 10 would bubble up, like we did before. Then we go to our next one. Interval heap is greater than 0, the length of the heap is, and then the start is greater than or equal to the top element of the heap. So we're going to heap pop, get rid of our 10, and then we're going to heap push 20. Yeah, so we're pushing 20, not 15. I think I did 15 before. So yeah, 20 would be at the top. Return the length of the heap, 2 meeting rooms. Like before, we said we needed 2 meeting rooms, so that works out. And let's see, what example should we use? Yeah, I guess we can just add something in here, or add a few things. Let's do like 15. No, we'll just do like 9 and 25. Then just 1 to 6, something like that, right? And then if we draw our graph again, we can do like 1 through 30, 5 to 10, 15 to 20, 5, 10, 15, 20, 25, 30. And then 9, 25. And then 1 to 6. Alright, so it looks like 3 is going to be our number here. Right here, here, and also here. But it's always just going to be 3, so we're going to need 3 rooms total for these meeting times. So yeah, we're going to sort this, and yeah, we're just going to sort it, and then, okay, I'll just write the sorted order, 0, 30, 1, 6, and we're sorting by the start. I should specify that. 1, 6, 5, 10, 9, 25, 15, 20. And then same thing, we put in 30 into our heap. 1 is not greater than, or 1 is not less than 30, so we'll add that in. 6 is now the root of our min heap. 5 is not greater than, or the root of our heap, so we'll also add that in. Like so. So we have 3 already, but we need to continue. So 9 is actually greater than our root, so we'll replace this with the 25. But we would have to bubble up, so our new one would look like this. And then 15 is also greater than our 5, so we would have to replace our 5 at the end. Which is 20. What is the length of our heap? It is 3. Return, we would get 3. That is the answer of how many meeting rooms we need. So this is the heap solution. There's other solutions you can see on Leetcode, but this is the easiest one, I think, as long as you kind of understand how heaps work and they're not too complicated. Yeah. Thanks for watching.